All right, so in this problem, what we're asked to do is first label each chemical species as an acid, a base, or salt, or something else, I guess, if that comes up. And then predict the products of each reaction. And then we're also going to need to decide if it's a reaction that will go to completion or an equilibrium reaction. And that distinction is really, really important, especially in this general chemistry class. So let's just go ahead and get started, jump right into it. We'll talk more about what's going on and what I would expect as we go through. The first thing I'm going to see, CH3COOH, right away we should recognize that as a weak acid. This is the sort of most common weak acid that we're using as an example in general chemistry. This is a strong base. So I can recognize sodium hydroxide right away as a strong base. And then anytime we have a strong acid or strong base reacting with a weak acid or weak base, the strong acid or strong base is going to drive that reaction to completion. And we can talk more about that if you'd like, but essentially what I'm going to do is I'm going to draw a reaction arrow to the right, and then I'm going to predict the product. So if the strong base is reacting with the weak acid, one of the products is going to be water. So we can start with that, H2O, and then I'm going to have my conjugate base, CH3COO-, and then I'm going to have Na+, which would be my spectator ion. Now, in this case, if we imagine, and the problem does not specify, but if we sort of imagine a 1-to-1 mole-to-mole ratio, then all of this would be consumed, right? All of the weak acid would be consumed, all of the strong base would be consumed, and these products, that's going to be sort of what's present in my solution after that reaction has occurred. Now, I recognize this CH3COO- as a weak base. A number of ways we could recognize that. The best, I think, is because we know that it's the conjugate base of a weak acid. Conjugate base of a weak acid is always going to be a weak base. The conjugate acid of a weak base is always going to be a weak acid. So since that's a weak base, that weak base could have a Kb type reaction going on with water. That's going to be an equilibrium to reform that acetic acid just a tiny bit plus OH-. This is going to follow the general form of a Kb. So our secondary reactions in all of these cases, they should always follow either a Ka or a Kb. They should all be equilibrium reactions, and they should only sort of be one set of them. So here I've got my Kb point of view, and that's really it. So the next one, NaCl plus water, I'm going to skip this one. This is just going to be Na plus Cl minus, so I don't need to worry about it. The next one, HCOOH plus water, this is going to be a weak base, a weak acid. So we're going to label that as weak acid. H2O is obviously water. And this is going to be an equilibrium reaction. So this is just putting a weak acid into water. I can recognize it as a weak acid. The COOH is the giveaway there. And we're just going to write this out, sort of follow a Ka. So HCOO- plus H3O plus. I'm putting H3O plus since I've got the water in there. And again, that would follow the general form of a Ka. Let's do the next one, sodium fluoride plus water. So in this case, again, sort of just like the NaCl one that we skipped over, I'm going to be forming Na plus ions plus F minus ions. Up here, it would just be Na plus Cl minus, but neither of those are going to do anything. Again, the sodium is going to be a spectator ion, but the F minus, I can recognize F minus as a weak base. And if you're not sure about this, the next exercise will be how we figure that out. So if you're not sure about F minus, the way that we're going to do that is we're going to say, well, let's imagine it reacted as a weak base. What would that look like? Well, what that would look like, following the general form of the Kb, is a reaction that looks like this. F minus plus water goes to HF plus OH minus. That's my Kb type reaction. And I recognize HF as a weak acid. If F minus is the conjugate base of a weak acid, that means F minus must be a weak base. So this reaction here is going to proceed. It is going to be a reaction that will, an equilibrium that we should consider. So that would be my secondary reaction for D. Let's go ahead and do E. This is a weak base. This is going to be one that's a little bit harder for us to identify. HNO3, strong acid, we should definitely be able to do that. Since I've got a strong acid, that's going to be a reaction that goes to completion. This weak base, I see the NH2, so this C6H5NH2, if I wanted to draw that out in sort of a Lewis type diagram, simplified Lewis diagram, it's going to look like this. So we've got this ring, we've got the NH2 group up there, and that lone pair of electrons on the nitrogen, that's going to be the sort of base site that it can react as a weak base. So weak base plus strong acid, we're going to end up with C6H5NH3+. plus NO3 minus. So this is going to be a weak acid. NO3 minus, that's going to be a spectator ion. It's not going to do anything else. It's not going to react with anything. So this weak acid, though, we could have our secondary reaction C6H5NH3 plus water is going to give us C6H5NH2 plus H3O plus. We should recognize this as a Ka. We don't have to include the water here, right? A lot of times in the Ka, we leave that off. We just have the weak acid dissociates into the weak base plus H plus. Here I've included the water, doesn't really matter. So that's what I would do there. Let's just keep going. NH4Cl. So again, I recognize NH4Cl as an ionic compound, as a salt. NH4, oh yeah, we didn't label these. Salt. NH4 plus Cl minus. Cl minus is going to be a spectator ion. The NH4 plus, though, is a weak acid. I can recognize that as a weak acid. This one, let's just write out like this. Let's be a little bit lazy. Plus H plus Ka. So here I've left the water out of my Ka. Again, doesn't really matter. Either way is totally fine. But that's going to be a weak acid. I can recognize that for a variety of reasons, I guess. I know that NH4 plus is a weak acid. I've seen it quite a bit. I know that NH3 is a weak base. It's on my list of weak bases. So that'd be another way to recognize it. Here, strong acid. We just said NH3 is a weak base. Reaction is going to go to completion. I've got a strong acid driving that reaction. NH4 plus Cl minus. Again, the NH4 plus, obviously a weak acid. Let's just change it up, go back and forth here. Add the water in this time. Again, does not matter at all. NH3 plus H3O plus. Again, that should follow the general form of a Ka. So that's all the ones that I'm going to do for this video. Hopefully that helps, makes a little bit more sense. Always, let's put some notes here. Reaction that goes to completion first, then equilibrium. And that should be a Ka or a Kb. That's sort of where we're at right now. Yeah, hope that helps.